No, if it's bad, it still will stay for a long time. And I'll tell you it looks good. No, I have full confidence in you, Skylar.
Don't bring up the trees.
Hey. All right, today we're looking at rationalizing the denominator. Amber, one thing that's important for you to know is you can use all notes on tests. So I would recommend trying to write some things down as we go through this stuff. Rationalizing the denominator. Yeah, which I think we've done before. Does this sound familiar at all? Did we do this a little bit last trimester? Maybe 2 trimesters ago, but we definitely, I think, have rationalized denominators before. This lesson shouldn't be, like I said, we're familiar with this, so it shouldn't be like over the top, mind-blowing, but it's not super, super easy. It's not just like an off day or anything like that. So our goal for today is to be able to rationalize the denominator of a fraction that has a square root. Now, the reason we're rationalizing denominators is because that helps us write fractions and helps us write things in simplest form. Okay? Now here are the 3 checks that we have to make sure that something is in simplest form. So a radical expression, or really any expression that involves a radical or a square root sign, is in simplest form when these 3 things are met. No radicand, I should say has a perfect square. That is bad color green, isn't it? So what that would mean is that if we look at something like the square root of 20, what we learned last trimester is we can rewrite this as the square root of 4 times 5, right? We want to rewrite it as one of our perfect squares times something else. We can break this up as root 4 times root 5, and what is the square root of 4? 2. So this would be all the way simplified. So what this is saying is first, when an expression has a radical sign or a radicand involved, if we leave it as a square root of 20, that is not in simplest form. The simplest form would be to take any perfect square out of that radicand that we can. That's condition number 1. Condition number 2. No radicands contain a fraction. So if we had the square root of 3 over 4, this would not be in simplest form. We cannot have a fraction underneath a square root and say that it is in simplest form. And we'll look at today how we would simplify this. So I'm not going to, I think we already know how, but I won't go over it this time. Third condition, no radicals appear in the denominator. So we do not like radicals in the denominator, like this. Now with this example, 7 over root 16, what can we simplify that to? Yeah. But if we had something like 2 over root 10, can we just simplify the square root of 10 easily? We can? What's the square root of 10? No, we can't. So this is kind of what we're learning that's new today. What we would look to do then is rationalize the denominator. Rationalize the denominator, or get that square root out of the denominator. So let's look at our first example. If we are told to simplify the square root of 1/3, do you guys remember what we would do to simplify this, or how we could look to simplify this? If you don't, that's okay. You have an idea? What do you think? It's okay if you're wrong, it doesn't really matter. You being wrong is better than, nothing. Blur! You're killing me. What we would look to do is give the square root to the top and to the bottom. Is that what you were going to say? No, I won't. That's where you say, yeah, that's what I was going to say. Even if it's not. Because I won't know. We give the square root to the top and to the bottom. Now, what's the square root of 1? good. So we can simplify it to this right here. But, like we talked about, one of our rules is we do not like square roots in the bottom of our fraction. So what we look to do is rationalize the denominator. Now what that means is that, again, we're taking the square root out of the denominator of the fraction. Does anyone remember how we do that? We multiply this 1 over square root of 3 by something. Good idea, but not quite. To get that square root out of the bottom, we multiply by the square root of 3 over the square root of 3. So we multiply by this denominator. Now, we are allowed to do this because if we take like 4 over 4, what does that equal to? If we take root 3 over root 3, what does that equal to? 1. So here, we technically are just multiplying by 1, right? So we're allowed to, we're not just bringing in a random square root of 3 out of nowhere. We're just multiplying by 1, but we're multiplying by 1 in the form of square root of 3 over square root of 3. So when we multiply across, 1 times root 3 gives us square root of 3. Square root of 3 times square root of 3 gives us what? Square root of 9, yeah, which would simplify to what? Yeah, just 3. So that is why we decide to multiply by root 3 over root 3, because that gets rid of that square root on the bottom, and now this would be in the simplest form right here. What questions do you guys have? Okay. Let's. Oh, no, I wrote it up here on the bottom. You guys do this one on your own, square root of 1/5. Solve it, put it in simplest form. Once you do that, then you can get started on your assignment, which is in Big Ideas. This scale that we just worked on here pretty much covers the first 8 or 10 problems in Big Ideas. And then after you guys work on those for a little bit, we'll come back together and I'll have to introduce one more skill for you to do the last 4 or 5 Big Ideas problems. But that's part 1.